How can wearable technology improve the health of our communities? Wearable technology can do more than count steps or monitor your heart rate. It is a scientific tool that can solve real-world environmental health problems.
This year's 4-H National Youth Science Day theme is wearable technology, and we're building a fitness tracker.
So we're curious, what is wearable technology and how do scientists use it?
I'm Brooke. I'm a junior at Howell High School.
I'm Nathila. I'm a sophomore at J.P. Stevens High School.
We help lead teen science cafes at Rutgers, New Brunswick.
We're talking to Dr. Lombok today to find out more.
Can you tell us where we are and what you do here?
Sure, it's a pleasure to be here with you today. We're here at the Environmental and Occupational Health Sciences Institute, which is EOC, we refer to it as, here on the Rutgers Bush campus in Piscataway, New Jersey.
What do these forms of wearable technology show us?
Well, basically what they can do is make the invisible visible. They can be very sensitive and extend our senses, so that in the case of particles, for example, very, very tiny particles, much smaller than the width of a human hair, which are invisible to us, these monitors can, with very sensitive detectors and very strong lights, essentially, they shine a light at the air that passes through the monitor, and then they can measure reflection back from these little tiny particles. Similar to if you have the experience of seeing particles of dust dancing in the air when there's a shaft of light, like in a dark room, perhaps coming through a window. Those particles, you can see them, and they're large enough to be seen by the naked human eye, whereas the particles that can get deep into our lungs tend to be particles that are much, much smaller, and particles that we can't see, even particles down to the size of a virus or a bacteria. So those particles, we need help from technology to be able to measure them. You know, a big part of science and technology in science, whether it's a microscope or a telescope, sort of being able to see and measure things that we can't normally see and extend our senses.
So why do you think that we need wearable technology?
Well, that's a good question. And again, my field, which is looking at air pollution and air quality and how that affects health, but a lot of air pollution, both comparing indoors and outdoors, as well as from one place to another, can have a steep gradient or a sharp decrease or increase. But to really measure that and measure it accurately, the ideal thing would be to have each individual have their own monitor to measure. And so this is actually an example here of a monitor that does measure ozone. Ozone is a colorless, odorless reactive gas comprised of 3 oxygen atoms found naturally in the Earth's stratosphere. Hot sunny weather with stagnant wind conditions favors ozone formation near the Earth's surface. Pollutants emitted from society's activities react in the presence of sunlight to form ozone. In New Jersey, we often see high ozone levels from May through September. And as you can see, it's about a couple ounces, 2 inches long. It actually has a readout that you can actually, minute to minute, look and see what the ozone level might be. But it also has a memory that allows us to record for up to a day, again, minute to minute, what the levels of exposure are. So again, if we're sitting here, it's relatively low. I go outside, it gets higher. I go out across to the cafeteria across the way here, maybe at lunch. I get some exposure. Having that information over time and having with a lot of people, if these get cheap enough that everyone can have maybe one attached to their cell phone, that would allow us to do much more accurate studies about how ozone, in this case, is related to health conditions like asthma.
Can you tell us what you're currently researching?
Sure, we have a number of ongoing projects. One of the more interesting ones, I think, is that air pollution, as we talked about, isn't necessarily uniformly distributed. Like ozone outside is sort of a regional air pollutant, forms in the air and is sort of everywhere on a hot summer day. Whereas traffic-related air pollution, which comes primarily from the exhaust pipes of vehicles like trucks, buses, and cars, is much more concentrated along roadways, as you might imagine, right? So we are interested in how often people who live near major roadways and are then potentially exposed to much more traffic-related air pollution. So here we have a situation where the air pollution is higher in areas where people are more susceptible. So we have studies right now focused on Newark and Elizabeth, around the seaport there where there are a lot of trucks and a lot of highways, and looking at how asthma might be affected in children. And what this monitor is doing basically is measuring the blackness on a little filter that's inside. So it pumps air through a filter, and then the filter gets blacker and blacker as the day goes on. And it shoots a laser. You can actually see the filter here in a black spot. That's actually the accumulated soot that accumulates over the day. Shoots a laser at that spot, and then looks at how much of the light gets absorbed, right? Because black things absorb light, right? So it's a measure of the absorbance of the light.
And what inspired you to go into this field of science?
At the time when I was growing up was a time when there was like new interest in environment and in environmental health. And I think, there's been a lot of development in the field. It's been a very exciting field to be involved in. I'm looking forward to new things and new technologies that are on the horizon that can really improve what we can do to really try to help people's health.
We would like to thank Dr. Lombach for being here today with us.
Good luck building your fitness trackers.